SREB powerful mathematics practices include 5 major indicators. This video will focus on one of those indicators, ensuring a balanced approach to mathematics.
Good morning, boys and girls. All right, now we have a special lesson today.
A balanced approach places emphasis on student understanding of mathematics facts and procedures generated from applying mathematics to real-world or non-routine scenarios. Students not only have fluency with math procedures, but there is a confidence in selecting appropriate tools and strategies for a given situation.
Allowing different strategies is important to me because in math you can get the correct answer in so many different ways. It's just like life. You never know what problems you're going to face. One thing that I want to do, I want to refer back to the standards that we talked about at the very beginning of our lesson. For me, balance as far as the content and applying the knowledge and going from level to level knowledge is extremely important because all these steps are connected. Part of it is being procedural. You have to know what to do in the correct order. One way you can know what to do in the correct order is having that basic knowledge, that foundational knowledge in math that help you know what to do, when to do, and how to do. Now, you may not have had someone to read to you since you were little, but that's how we're going to start our lesson today with one of my favorite books, If You Hop Like a Frog. If you hop like a frog, you could jump from home plate to first base in one mighty leap. If you flicked your tongue like a chameleon, you could whip the food off your plate without using your hands. Could you imagine what life would be like if you actually had these superpowers? Well, we're about to find out. On your tables, you will see that there is a yellow card that has some facts on it. And I have it up here as well. So this is going to be your task. Using this information about the chameleons and their tongue sizes, along with the information you know about yourself and what is provided in the illustration, can we confirm or deny the author's claim? And not only can we prove to see if it's true or false, but also the second part of that. What mathematical argument and evidence can you prove to justify or support your decision? Because in math, we know we have to have some evidence for what we say. Now, what you can do at first is think about some ideas that you might have first, and then confer with your group members. But ultimately, your work is going to be on this think sheet.
So if we measured each other, then we would know how long a chameleon tongues would be on us.
Yes, it'd be half our size after we measured.
Yeah.
We should measure how tall we are.
Put your hand up.
Your tongue was like a chameleon.
63 inches.
You are, about 60 or 59 inches.
Okay, 5 foot,
Your tongue would
2.
it would have been 2.
And so half of 5 foot 2.
But they didn't say it like in the story. They said it was like inches. They were counting it in inches. They were.
Oh yeah, so we should just leave it in inches.
So your tongue would be
31 inches. Yes. Catherine's is 30.
31 and a half inches. And
We still need to measure it.
yeah. So if the chameleon's a foot, so his tongue is half his body.
yeah, because the chameleon. The chameleon's tongue equals 6 inches, right?
Yes.
So 6 inches is, hold on.
It's half his body length, which is a foot.
He was 12
inches.
long. That was his whole body.
Yeah.
His tongue was 6 inches.
So that means everything.
Yeah, 12. 6 times 2 equals 12. So
that means our height would just divide by 2.
yeah,
My tongue will be longer than your tongue because you.
by half an inch.
Yeah, my tongue will be longer than you by half an inch.
It depends how far you are, because if you're leaning over, you can.
Yeah, it would be a lot easier than if you were farthest back, because then your tongue would have to be longer.
we don't have an actual plate, but we can imagine that this is the size of the plate. And 31 inches is half our body size, and it could scoop up yeah.
If the plate is kind of smaller, your tongue doesn't have to be that large in order to whip your food out.
Yeah, but if it's bigger, it's gonna have to be larger, so you have to wrap around. So you can wrap around the plate. Yeah, you can have
And if you measure these numbers on living plates,
And also, it depends on what your height is.
So the bigger the plate size, the bigger you would have to be, like the taller you have to be.
Yes.
Some things for us to consider. How does David Swartz, who is the author, know that his statements are incorrect? And then, can we prove or disprove the conditional statements that the author claims using mathematics?
The teacher and the students articulate the mathematical goals of the lesson within the unit progression, linking the lesson with learning from previous instruction, and revisit the goals throughout the lesson.
Now, another part of our lesson is this. One purpose of doing this is what I call the OMGs of learning. When we're going to identify some obstacles that we have in our learning, that's the O in OMG, because sometimes we still have some misconceptions about ratios, rates, and proportions. The M, the misunderstandings, because sometimes after you learn something, you still have some misunderstandings where I clear up. And then G, the learning gaps. I don't know about you, but sometimes when I've learned stuff, I realize that when it's time to do work, there's still some information that I'm still missing. So we're going to go from there. Is that all right, boys and girls? Yes. All right. Now, each particular pair or group will be getting a different animal. And it's going to be your job to what you just did before. You're going to be doing very similar tasks, except with a different animal. Now, one thing to consider while you are working on this is to see how these learning objectives that we've talked about before relate to what you're doing right now. See if we're actually doing what the goals of our lesson say that we're going to be doing.
5 nanometers, 6'5".
And while you're doing that, remember your ultimate goal, because I'll be calling different groups, as long as you are able to explain, like, if what this David Swartz saying is true.
About what we can see, or like, because when we were reading the book, it said that we can see how high from the high up from the clouds. So can we see from the clouds?
Well, I would, if I were you, I would read the information and then carefully, correctly, and remember the standards that we were working on. What the standards said up there about converting units, and see and look at the units that you're going to be working with, and then discuss that with your group members. Think about this. If you want to make any revisions to your work based on some of the questions that your classmates asked. Like I know someone, I think it was Vaughn, just asked about how tall the person was, is from the rooftop or so forth, things like that. Consider these things. Also consider your measurements one more time to see if they're actually correct, if our math is actually accurate. Because in math, we know that our math has to be accurate. So hopefully with this lesson, one thing we hope that you did was that maybe you identified some gaps that you noticed, maybe some misunderstandings that you had earlier before the lesson, and maybe if those misunderstandings were corrected as a result of us doing this lesson. Yes, Kristen?
We had a lot of gaps, but we filled them
with knowledge.
Yes.
Mr. Foster.
Yes, sir.
We can measure you.
You're an average human.
Students analyze an assignment, independently choose appropriate tools needed to complete the assignment, and justify why the selected tools are appropriate.
We want to see the size of a plane and
Sure.
how big a human we have to be.
Absolutely.
Great. About 71 inches. 70 and a half. Yeah, about 70 and a half. Oh, can we use our Chromebook?
Absolutely, you can use your Chromebook. Believe me, even though I know I'm good at math, there are times where I gotta look up stuff too. So absolutely use your Chromebook.
Okay.
Based on what you told me, what access to other resources do you have?
The internet.
Ah, Exactly. Because, can I tell you a little secret? I'll tell you this little secret, okay? Even though I know I'm your math teacher, there are plenty of times where I have to look up stuff all the time. Like before I teach y'all, I have to look at stuff on the internet. I gotta research as well.
Yeah, you have to explain, because if you don't explain, you don't know that it's true.
There you go. All right, keep up the good work.
So how tall would a human have to be, or how big would they have to be for us to see them in a plane? Because we cannot see them from 5 feet.
Okay, we need to think of something to ask beings that, because I can't ask.
They do see rabbits, and rabbits aren't like.
Alright, we need to think this
Should we
through.
multiply this to get a number close to this?
Yes, I think so. Here, 240 divided by what?
5.8.
240
Yeah, just about like.
divided by what?
5.8.
41.37933103.
It'd be like little. And so if you had eagle vision,
Wow,
it'd be
this
like
is actually pretty interesting.
we can see that. Also, like we can see the outside.
It feels like science class a little bit.
Eye, so you see a rabbit hopping along. That's the thing that you would see.
Even right here it says, on a dark night you could even see a candle flame flickering up to 30 miles, aka 48 kilometers away. So that's why I put 30 miles, and yeah, it's converted that. So even with a regular human eye, we can already see a rabbit. But 5 times that would be, you can maybe see that from space with eagle eye, which I would love to have.
Now it's time for us to present to the class what you have found about your problem.
Students examine and use multiple procedures or strategies to solve a given problem, critique the different strategies, and apply the most efficient strategy to their work.
We had the ants, and what we decided was we took our weight and we multiplied it by 50, and my weight was 100 pounds, and I can lift up to 5,000 pounds or 2.5 tons.
We can also lift the average oak tree and 5 average ligers, which is a lion and a tiger hybrid.
So I want to tell you the equation that we used. We used W, or weight, times 50 equals what we can lift. And the way we found these out is 1 ton would equal to 2,000 pounds.
I heard I believe it was you, Carissa, who used a variable W. So you actually used algebra to solve this. Interesting.
Well, this math actually helped me learn that I was actually using algebra and not even noticing. It helped me learn that I can do math when I really try or when I work with a group, and I think I do it better when I'm working with a group as well.
What I said is that if it said on the paper that a spider could run 33 times its length, which in 1 second. So if I am 5 feet and 5 inches tall, I could run 182.5 feet per second.
So we drew a football field to explain how we could run each one of those, how far we could each run, and I explained that so we could both run past the 50 mark, but I would run to between the 50 and the 40 mark, and Jonathan would run between the 40 and the 30 mark because he's taller than me.
A human has 200 cones, which cones are cells inside your eye, which help you see. Eagles have 1 million, a million cones because it's 5 times, it can see 5 times farther than us. So what we did was just times it by 5, which gave us 1 million. So from knowing this information, we kind of did the rest of the problem from that one piece of information, because ratios and all that I understand and everything, but I have some gaps in that learning. So it really helped me working with people around me. So if you're in an airplane, we use this as an example to see what we can see. He gave us a quote one day, learning's not a spectator sport. He said, you don't sit and watch, because that's what a spectator is. You have to actually participate in the learning if you're going to learn something.
We could see most things from 1,500 meters with eagle vision.
Like how you added like a legend and you showed like what they can't eat, and
we compared 3 different things with the graph. That was pretty cool.
Thank you.
I think he made us present because we can't sit and watch someone else do it. We'll never learn it. We'll see it, but it doesn't mean it's going to stick to our brains as if we would do if we went up there and did it ourselves.
I noticed you used the number 50 in your question. Where did that 50 come from?
As emphasis is placed on deeply understanding and implementing the concept of powerful math practices, ask yourself the question: to what extent is a balanced approach to mathematics evident in your classroom, your school, and your district?